What if our universe is not alone? What if the stars above, the galaxies we chart, the cosmic background we measure, are only fragments of a far greater reality, one among countless worlds stitched together in an endless tapestry of creation? Cosmology whispers of such a vision, the multiverse, a vast expanse where universes bubble, collide, and vanish, each with its own laws of physics, each a separate dream of reality. And within our own sky, faint and fragile, there may linger relics, traces left behind by other worlds. A cold spot in the cosmic microwave background that should not exist. Patterns of radiation etched across the heavens, as though our cosmos brushed against another. Black holes that hint at hidden gateways. Equations that multiply realities far beyond the one we see. These are not proofs, but whispers. Forgotten relics scattered across the silence of space. If these relics are real, then our universe is not the whole story. It is a single page in an infinite book. A relic itself, born from a fire older than memory, destined to fade, but not alone. And so we stand at a horizon of thought as profound as any in science. The question is no longer just where did we come from, but are we only one among many? This is the journey into the forgotten relics of the multiverse. The scars, the echoes, the mathematical fossils that suggest infinity is not imagination, but architecture. The traces of other worlds hidden in our own. The story begins not with stars nor with galaxies, but with the birth of time itself. The Big Bang was not an explosion in space, it was an explosion of space. In less than a fraction of a second, the universe leapt from subatomic scales to cosmic proportions. This was the fire of creation, the moment when the laws of physics first found their voice. But hidden within this fiery birth is a deeper possibility, that our universe was not unique. That the same process which gave rise to our cosmos could give rise to countless others, each born from the same inflationary storm, each a seed in the soil of eternity. In the late 20th century, physicists faced puzzles the Big Bang could not answer. Why was the universe so uniform in all directions, its background radiation nearly the same everywhere? Why was space so flat, its geometry stretched without curvature? The answer came with the theory of inflation. In the first trillionth of a trillionth of a trillionth of a second, the universe expanded at unimaginable speed, faster than light, ironing out irregularities, stretching quantum fluctuations into the seeds of galaxies. But inflation carried a revelation. In many versions of the theory, it does not stop everywhere at once. It ends here, then there, in pockets. Some regions keep inflating, spawning new bubble universes. Each bubble becomes its own cosmos, with its own history, its own laws. Our universe may be one bubble among infinite others. In this vision, inflation is not a single event, but eternal. The cosmos is not one universe, but a froth of universes budding endlessly. Each bubble expands and cools, forming stars and galaxies. Between them lies an inflating sea, forever spawning new worlds. If so, our Big Bang was not the beginning of everything, but the beginning of one universe among many. The multiverse is born not from speculation alone, but from the natural consequence of inflation itself. The multiverse is not just many copies of the same. If physics allows, each bubble may have different laws, different constants, different dimensions. One universe where stars never form, another where gravity is weaker, another where life is impossible, another where it thrives in forms unimaginable. Our own cosmos, then, is a relic, one configuration of laws among an infinite landscape of possibilities. forgotten unless observed. Precious because it exists at all. To imagine the multiverse is also to imagine fragility. Our universe is not eternal, but one bubble in an ocean that will outlive it. What seems infinite to us is, in this vision, only a fragment. The multiverse reframes eternity itself, not as a single endless expanse, but as a sea of vanishing points, each universe finite, each destined to fade. And yet, within this fragility lies wonder, for it means our existence is not inevitable, but extraordinary. Out of infinite possibilities, we are here, in this universe, at this moment, to wonder at the relics of others. Beneath the vastness of cosmic inflation lies another kind of infinity, one hidden in the smallest scales of existence. The quantum world is a mirror that reflects not certainty, but possibility. Particles exist in multiple states at once. Light behaves as both wave and particle. Electrons move not along one path, but all paths simultaneously, until something forces them into place. For decades, physicists struggled with this paradox. Why should observation collapse possibilities into a single outcome? Why should reality choose one version of events while discarding the others? One radical answer emerged. Perhaps nothing is ever discarded. Perhaps reality never collapses at all. Instead, it branches. Every possible outcome occurs, but in separate universes. This is the many worlds interpretation. A coin tossed into the air lands both heads and tails, but in different realities. Each time a quantum event unfolds, the cosmos splits, branching into countless versions. When you look, you follow one branch, but the other remains unseen, just as real, just as inevitable. In this vision, our universe is not a single unfolding story, but one among infinite narratives fracturing at every moment. Reality itself becomes a forest of branching paths, each filled with galaxies, stars, lives, and choices. We cannot see the other branches, yet the mathematics suggests they exist. Our world is one leaf on an endless tree. If this is true, then relics of these other branches may remain. Subtle interference patterns in experiments, faint echoes of possibilities bleeding through. Quantum physics already shows us hints of this, in double-slit experiments, in the strange coherence of particles acting as though they know of alternatives. Though invisible to us, these phenomena may be the whispers of other realities brushing against our own. Forgotten relics not carved into the sky, but etched into the mathematics of the microscopic. And yet, the implications stretch beyond physics into philosophy. If every possible version of you exists somewhere, who are you? Are you bound to one branch, or are you scattered across many? Some argue that this diminishes individuality, that if infinite variations of you exist, your choices lose weight. But others say the opposite, that meaning deepens because our path is ours alone. The existence of other lives does not erase this one. Lived fully, loved fully, remembered fully. The quantum mirror does not steal our identity. It refracts it into endless reflections. In this vision, eternity is not a line stretching forward, but a fractal branching endlessly in all directions. Every moment contains within it the seeds of universes unseen. Every choice is not a closing, but a multiplication. Infinity is not distant, but woven into the fabric of every instant. And if universes multiply in both the vastness of inflation and the intimacy of quantum branching, then our cosmos is doubly not alone. It is one bubble among countless, one branch among endless. The multiverse is written both into the expansion of galaxies and into the trembling of particles. If this is so, then we must ask, can these other worlds leave marks upon our own? Can their presence be glimpsed not just in mathematics, but in the sky itself? The oldest light of the cosmos may hold the answer. In the faint glow of the cosmic microwave background, there may be scars, imprints of collisions with other universes, written into the afterglow of creation. The night sky holds more than stars. Behind the constellations, beyond the galaxies, lies a faint and ancient glow, the afterlight of creation itself. This is the cosmic microwave background, the first light freed when the universe was only 380,000 years old. It is the oldest picture of the cosmos, a fossil etched across the heavens. At first glance, it is astonishingly uniform, the same in every direction, to within a fraction of a degree. Yet within this sameness lie subtle ripples, tiny fluctuations in temperature, variations in density that became the seeds of galaxies, clusters, and the cosmic web. It is a canvas painted by the infancy of the universe. But some of its strokes do not fit the pattern. Among them lies a mystery, a region known as the cold spot. It is vast, stretching across hundreds of millions of light years, and colder than its surroundings. Too large to be explained easily by chance, too strange to be dismissed entirely. What caused it? Some suggest it is the shadow of a massive void, a region of space with fewer galaxies, cooling the light as it passed through. But others whisper of something deeper, that the cold spot is a scar left by another universe colliding with ours in its infancy, a bruise in the afterglow of creation, a relic of a forgotten world. If eternal inflation is real, then bubble universes may form, expand, and sometimes collide. These collisions could leave imprints in our cosmos, subtle signatures etched into the microwave background, circular patterns, alignments that defy randomness, anomalies that resist easy explanation. Each one a possible relic of other worlds brushing against ours before drifting away forever. Satellites like WMAP and Planck have mapped the microwave background with exquisite detail, revealing these anomalies with increasing clarity. None are yet conclusive, but they whisper of something beyond. Like fossils in stone, they may be the relics of universes we will never touch, their traces lingering in the faintest glow of our own sky. The search for such scars continues. Some scientists argue that they are nothing more than chance alignments, that our minds are too eager to see patterns in noise. Others insist the anomalies are too persistent, too peculiar to ignore. Between skepticism and possibility lies mystery, and mystery is the horizon of discovery. If these scars are real, then our universe has a history far older than its own. It has been shaped not only by its birth, but by brushes with neighbors, collisions with realities beyond. The cosmic microwave background becomes not only a fossil of our cosmos, but a palimpsest, a layered record, with faint echoes of other worlds hidden within it. And yet, even if no scar is ever confirmed, the search itself reveals something profound, that we are willing to look for relics beyond our horizon, that we are driven to peer into silence, to ask if our universe carries the fingerprints of others. This impulse, to search for what may never be proven, is itself a relic of the human spirit. But relics may not only linger in light, they may also dwell in the darkest places of the cosmos. For if there are gateways between universes, if there are thresholds where one reality spills into another, they may lie within the most mysterious of all horizons, the black holes where time itself falls silent. Black holes are the most enigmatic structures the cosmos has ever conceived. They are not stars, though many are born from stellar death. They are not matter, though they possess mass beyond imagination. They are regions of space-time where gravity becomes so absolute that nothing, not even light, can escape. From the outside, they appear as shadows, dark spheres outlined by the glow of falling matter. But within, they conceal horizons, boundaries where physics falters. At their cores lies a singularity, a point where density becomes infinite, where space and time curve so violently that our equations break apart. In the traditional view, a black hole is a tomb. Everything that crosses its horizon is lost forever. Yet some physicists have dared to ask, what if black holes are not graves, but gateways? What if they are the most ancient relics of the multiverse, seeds of new universes hidden within our own? Einstein's theory of relativity allows for such speculation. Within its equations lie solutions that connect different regions of space-time, wormholes, bridges between distant points. Most would collapse instantly, unable to remain open. But what if the singularity of a black hole leads not to destruction, but to creation? What if, beyond its horizon, the compressed matter and energy ignite a new Big Bang, birthing another cosmos? In this vision, every black hole becomes a cosmic womb. Our own universe, too, may have been born from such a singularity, the offspring of another world. If so, black holes are not only ends, but beginnings, forgotten relics of eternal branching, each horizon a doorway to realities unseen. Stephen Hawking complicated this picture. His discovery that black holes emit faint radiation, now called Hawking radiation, revealed that they are not eternal. Over unimaginable timescales, they shrink and evaporate, dissolving into silence. Yet this deepened the mystery. What happens to the information carried by what falls in? Does it vanish, breaking the laws of quantum mechanics? Or is it preserved, encoded somehow on the horizon like a cosmic hologram? Some theorists suggest that this information does not disappear, but may be reborn, written into the fabric of a new universe on the other side. In this way, black holes become archivists of reality, storing the relics of our cosmos and carrying them into new worlds. If this is true, then every black hole is a relic twice over, a remnant of a collapsed star and a seed of something beyond. To us they are silent, inscrutable, unreachable. Yet within their horizons may lie the fingerprints of other universes, woven into the silence of singularities. To imagine black holes as gateways is to blur the line between ending and beginning. They become thresholds, where destruction and creation merge. What we call annihilation may in truth be transformation. What we call silence may be the first whisper of another song. In this sense, black holes are not only physical mysteries, but philosophical ones. They challenge our understanding of boundaries, of information, of eternity itself. They remind us that the deepest vanishing points of physics may also be the birthplaces of new infinities. And yet, the relics of the multiverse may not be confined to horizons of darkness. They may also be written in the abstract language of mathematics. For when physicists probe the equations that govern reality, they find not one solution, but countless. The multiverse may be encoded not in the sky or in black holes, but in the very structure of mathematics itself. Long before telescopes traced the light of galaxies, mathematics whispered of realities unseen. Equations are more than descriptions. They are blueprints of possibility. They tell us not only what exists, but what could exist. And within their symbols, physicists have discovered landscapes far larger than any universe we have measured. At the frontier lies string theory. In this framework, the fundamental building blocks of matter are not particles, but tiny vibrating strings of energy. Each vibration corresponds to a particle, an electron, a quark, a photon. But these strings cannot be described within the familiar fabric of 3 dimensions of space and 1 of time. To be consistent, string theory demands hidden dimensions, curled so tightly that we cannot perceive them. The geometry of these hidden dimensions dictates the very laws of physics we observe. The strength of gravity, the behavior of forces, the mass of particles, all are written into the folds of dimensions too small for us to see. And here lies the revelation. There is not a single way to fold these dimensions, but billions. Each possible configuration gives rise to a different universe, with its own constants, its own rules, its own fate. Physicists call this the landscape problem, a vast mathematical terrain of possible worlds. Our universe is one valley in this infinite expanse. The relics of the multiverse are not fossils in stone or scars in the sky, but the countless solutions hiding in equations. They are forgotten not because they are invisible, but because they are overwhelming, too numerous to grasp. If all these universes are mathematically possible, why this one? Why do we find ourselves in a cosmos where stars ignite, where chemistry thrives, where life can emerge? The anthropic principle offers one answer. We are here because this universe permits observers. Out of the infinite possibilities, only certain configurations allow beings to ask the question at all. We inhabit one of those rare islands of order, but such reasoning unsettles. It suggests our universe is not chosen, but incidental, one relic among countless others, no more special than a pebble on an endless shore. If every possibility is realized somewhere, then what does it mean for this one to exist? Some philosophers argue that this abundance dilutes meaning, that infinity erases significance. If every outcome occurs in some universe, why should ours matter? But others see it differently. Infinity does not erase meaning, it magnifies it. For within an endless sea of possibilities, the fact that this one exists, the fact that we are here to wonder, becomes even more extraordinary. Some go further still. They suggest that mathematics is not merely a description of reality, but reality itself. In this mathematical universe hypothesis, every consistent set of equations describes a real universe. In this view, infinity is not speculative, but inevitable. The relics of the multiverse are not scars in the sky or anomalies in light, but the equations themselves, whispering of worlds beyond measure. If so, then infinity is not only external, it is built into the logic of numbers, into the structure of thought. Forgotten relics may be hidden not in distant galaxies, but in the very mathematics that makes sense of them. And yet, these revelations lead us back to a deeper question. What does such infinity mean for us? If everything possible exists, does anything matter? If our universe is but one of countless, how do we find meaning in our own fragile horizon? Infinity is both beautiful and terrifying. It expands the mind, yet it unsettles the heart. To imagine a multiverse is to imagine a reality where nothing is unique, where every possibility is realized somewhere, where our universe is but one among countless. For centuries, humanity clung to the idea of centrality. Once we believed Earth stood at the center of creation. Then Copernicus shifted us aside. Galileo revealed other worlds, and modern astronomy unveiled galaxies without number. Each revelation pushed us further from the center, yet also gave us a deeper, more humbling sense of wonder. The multiverse pushes us further still. It whispers that not only is our planet not unique, nor our galaxy, nor even our universe, but perhaps no aspect of reality is singular at all. Every configuration exists somewhere. Every outcome is played out. We are one thread in an infinite tapestry. Such a vision raises a profound question. If uniqueness vanishes, does meaning vanish with it? If there are infinite versions of you, infinite lives unfolding with every possible decision, what does your path matter? Does choice hold weight in a cosmos where all choices are realized? Some see this as the erosion of significance. Others see it as its deepening. Meaning, they argue, does not require uniqueness. It requires immediacy. You live this branch, this moment, this life. The existence of others does not erase it, any more than the existence of other sunsets erases the beauty of this one. Meaning is found not in rarity, but in presence. The multiverse also fractures certainty. If infinite realities exist, then truth itself becomes relative. What is true here may not be true elsewhere. What laws govern this universe may fail in another. Can truth survive infinity? Or is it always bounded by the horizon of one world among many? Perhaps this is the most unsettling relic of the multiverse. Not the scars in radiation or the mathematics of string theory, but the dissolution of certainty itself. Infinity shakes the foundation of meaning. It forces us to confront the possibility that significance is not cosmic, but local, created within horizons, not beyond them. Yet, in this fragility lies something profound. Meaning need not stretch across universes to matter. It need not endure in infinity. It is enough that it exists here, within our narrow horizon of consciousness, within our fleeting span of time. In fact, perhaps it is the very finitude of life that gives it weight. If everything lasted forever, if every possibility were eternal, nothing would hold urgency, nothing would hold value. The multiverse, then, is not only a physical speculation, but a philosophical mirror. It reflects our assumptions about importance, uniqueness, and purpose. It asks whether we can find meaning not in the guarantee of eternity, but in the fragility of a single moment. And in that reflection lies a forgotten relic of its own, the awareness that wonders at infinity, even while confined to a finite world. But philosophy alone does not satisfy science. The human spirit still longs for evidence. If the multiverse is real, can we detect it? Can we trace its relics not only in thought, but in data? Can we find echoes of infinity in the instruments of our age? The multiverse is a vast idea. But science does not rest on visions alone. It asks for evidence, for traces that can be seen, measured, tested. And so physicists search for echoes, faint imprints of other worlds hidden within our own. The first place they look is in the oldest light, the cosmic microwave background. If our universe once collided with another, the afterglow of the Big Bang might still carry the scars. Circular imprints, unusual alignments, strange anomalies in temperature. These could be the bruises of ancient encounters. Satellites such as WMAP and Planck have mapped the sky with exquisite detail. They revealed peculiarities, the cold spot, alignments across vast scales, asymmetries that defy neat explanation. None are proof, but each is a whisper, a hint that our cosmos may have brushed against others. Yet the microwave background is not the only canvas. Gravity itself may carry the signature of other universes. In 2015, humanity first detected gravitational waves, ripples in space-time from colliding black holes. These waves confirmed predictions of Einstein's relativity, opening a new window on the cosmos. Some scientists believe that if bubble universes collided in the inflationary sea, they would have launched gravitational echoes into existence. If we can detect these primordial waves, we may glimpse not only our birth, but the birth of others. Instruments like LIGO and Virgo already hear the cosmic symphony of merging stars. Future detectors, such as the space-based LISA, may reach deeper, listening for whispers from the dawn of time itself. If those whispers reveal patterns too strange to belong to our universe alone, they may be relics, echoes of worlds beyond. The search extends to the smallest scales. In particle accelerators like the Large Hadron Collider, physicists probe the foundations of matter, smashing particles together at energies that mimic the early universe. Some hope to find signs of hidden dimensions, as predicted by string theory, or unusual particle behaviors that hint at realities beyond our own. If such signatures are found, they would be relics not of galaxies, but of the equations that allow multiple universes to exist. But the challenge is immense. If other universes exist, they may be forever beyond our reach, separated by horizons that no light, no signal, no traveler can cross. The best we can hope for may be indirect evidence, scars, echoes, anomalies. Proof may never arrive. The multiverse may remain forever a hypothesis, supported by theory and whispers, but never confirmed. To some, this is a weakness. To others, it is the essence of science. To reach toward horizons even if they remain unreachable. For the search itself is meaningful. To listen for echoes is to declare that we are not content with the visible, that we are willing to stretch our imagination into the unknown. Perhaps the greatest relic of the multiverse is not in the sky, nor in the particles, but in us. The impulse to wonder, to ask, to search for echoes of infinity. This too is a trace of something larger. Even if we never find conclusive proof, the very act of seeking reveals our place. Finite beings daring to question the infinite. And yet, the final relic may not lie in data at all. It may lie in reflection. For even if the multiverse exists, even if infinity multiplies endlessly, we must still ask, what does it mean for us? What is our place among many? If the multiverse exists, then our universe is not singular. It is one bubble among countless, one branch among endless, one relic among many. Against such vastness, a question rises like a shadow. What is our place? It is easy to feel diminished. If infinite versions of ourselves exist, are we unique at all? If every choice plays out somewhere, does choice hold meaning? If the universe itself is a relic, what value does it have? But perhaps meaning is not erased by infinity. Perhaps it is framed by it. For within endless possibilities, this one remains ours. This earth, this sky, this fragile span of years. The fact that there may be others does not make this less precious. It makes it more extraordinary. A sunset is no less beautiful because other sunsets burn elsewhere. A life is no less profound because other lives unfold. Meaning does not require uniqueness. It requires presence. To be here, now, aware of wonder, that is enough. And perhaps the greatest relic of the multiverse is not out there, but within us. Awareness itself. The fragile spark of consciousness that can imagine infinity even while bounded by finitude. Out of the silence of matter and the fire of stars arose beings who could ask, "Are we alone?" Awareness is a relic rarer than any galaxy, rarer even than universes. It is the cosmos reflecting upon itself for a moment before fading back into silence. Our place among many is not to conquer infinity, but to witness it, to marvel at the possibility of countless worlds, and to cherish the one we inhabit. We are finite, yet we carry the capacity to imagine the infinite. That is our gift, our burden, our wonder. And so, the forgotten relics of the multiverse are not only scars in ancient light, not only horizons of black holes, not only equations multiplied into infinity. They are also us, fragile creatures of dust who dare to ask what lies beyond. Even if the multiverse remains forever unproven, our questions are themselves relics of meaning. The universe feels complete to us, but perhaps it is only a fragment, a page torn from an infinite book. The whispers are faint, a cold spot in the sky, a horizon that hides its secrets, a formula that opens to endless solutions. These may be nothing, or they may be fossils of worlds beyond. If the multiverse is real, then eternity is fractured. Infinity scatters itself across horizons. Our universe becomes one relic among countless others. But meaning is not lost in this immensity. It is found in the fact that we are here at all, able to wonder, able to ask, able to imagine relics beyond our reach. Someday, the scars may be explained away. Someday, the anomalies may fade beneath clearer data. Someday, the multiverse may remain forever beyond proof. But the relics endure, not only in the cosmos, but in us. In our memory, our curiosity, our fragile awareness that reaches beyond its horizon. The multiverse may be infinite. Our lives are not. But in the brief light we carry, we touch infinity. We hold it for an instant, then let it go. And perhaps that is enough. So when you look up at the night sky, see not only stars and galaxies, see fossils, see relics, see fragments of stories that may never be told. And remember, even if eternity vanishes into silence, the wonder of being here, now alive to ask the question, is its own infinity.